Assalamualaikum and good morning to one and all. Today we'll study about bioassay of histamine using guinea pig ileum matching method. I am Sheikh Abu Sufyan. Welcome to my YouTube channel Pharma Learning Forever. At the end of this e-learning session, you are able to discuss requirement and procedure of this experiment, explain receptor binding of the histamine, and draw DRC of the histamine and calculate unknown concentration. So let's start with the requirement of this bioassay. So if looking at its requirement, the most important requirement which were not there in earlier experiment is it is about the animals. So the animal that we are using here, it is a guinea because the guinea pig ileum, it is more sensitive to the histamine. So whereas in earlier practical we have used the frog rectus abdominis preparation, we have used the rat ileum. So this is the experiment where we are using guinea pig ileum because in case of histamine it is more sensitive to the guinea pig ileum only. It means the histaminergic receptor, they are present more in case of the guinea pig ileum. That is the reason why we are using guinea pig ileum to perform this experiment. Whereas basal tension, it is same as earlier experiment, that is the 0.5 gram. Then drug we are using, it is the histamine, that is we are using both the standard and the test solution for which we need to calculate concentration. Because in case of standard we know the concentration, whereas in case of the test solution the concentration we are not aware of and we are going to calculate it by using matching bioassay. Next thing, it is physiological salt solution. Since we are using the ileum, the physiological salt solution, it is same as the rat ileum. So we are using the thyroid solution as a physiological salt solution because tissue it is same. Then contact time, it is the 60 second. So 60 second is the contact time. Magnification, again it is same, that is in between 5 to 7 times. So this is about the requirement of the experiment. So let's go ahead and see what is the procedure for this particular experiment. So for this experiment, first important thing is isolation of the guinea pig ileum. So you need to sacrifice the guinea pig and then you can isolate ileum from his abdominal part. Okay. So once isolation is done, then that isolated ileum can be mounted in the tissue organ bath with thyroid solution. So this is tissue organ bath, so in which you can mount the tissue and then the one end you can tie with the aeration tube and another end you can tie on the lever. So this is the lever where you can tie it by using the thread. Okay. So once you have tied with the thread on the both the end at towards the aeration tube and at the lever, then the mounting of tissue it is done. And what you are adding in this tissue organ bath, so in this particular tube, you are adding thyroid solution, which is the physiological salt solution required to keep this guinea pig ileum alive. Okay. So the mounting of tissue, it is same as the earlier procedure. Then after relaxation of the tissue, you can record dose response curve of the histamine. So you have to allow this tissue to relax. So for relaxing the tissue, what you need to do is the second load, that is the extra load that you have kept, that is the 1 gram, so that you need to keep down and you have to give washing for every 5 minutes. So when you apply this load, so that is the tension, so it will help to this tissue to get relaxed, because when you remove the tissue after sacrificing the animal, the tissue it is generally present in contraction mode. So to relax the tissue, first you have applied the extra load and then every 5 minutes you are giving the washing, because the relaxation of tissue it is very important for getting the reproducible and reliable responses. So second thing, it is you need to relax the tissue and then you can start recording the dose response curve. Once DRC of standard histamine it is done, then you can select the test dose and the match dose of the standard with the response height of the test. So this detailed procedure we'll see when we draw the dose response curve, that how we are going to match dose of the standard with the response height of the test. So two important things are there. So first you are taking the DRC. So this is the first step. Second thing you are doing, you are selecting the test dose. So the test dose you are selecting, that must be in between the dose response curve. It means it should be bigger than smaller dose of the at the DRC, and it should be the smaller than bigger dose which is there in the DRC, right? Once that selection of test dose it is done, then you are giving the different doses of the standard in a such a way that, or till the point you are giving the dose of the standard, okay, where your dose of the standard or response height of the standard, it matches with the response height of the test. So since here in the procedure you are trying to match dose of the standard with the response height of the test, this type of bioassay, it is called as matching bioassay. So two important things are here. The drug that we are studying, it is the histamine, and since we are studying the histamine, we have used different animal, that is we have used the guinea pig and we have used the guinea pig ileum to perform this bioassay, because guinea pig ileum have more sensitivity towards the histamine. So this is the first thing. Second important thing is that we are finding out unknown concentration of histamine by using the matching bioassay. So we are using the matching bioassay. Okay. So this is all about the procedure. Then let's see about the time cycle of our histamine. And sorry, there is some typo mistake is there. So just I am correcting this. Okay, so let's see about the time cycle of the histamine. So parameters and the drug that we have used. So first parameter, it is the baseline. So baseline, it is as always, it is same, there is no change. So you are taking the baseline of first 30 seconds where you are not adding the drug and you are starting the drum, so that you get response in absence of the drug. So do remember the baseline, it is the response in absence of the drug. Second thing is that the contact time. So contact time, it is the 60 second. Washing, you are giving the 60 second one washing. So 60 second each. So you are giving total 3 washing. So since one washing, it is of the 1 minute or 60 second. So total washing period, it is of the 3 minute. Okay. So total washing period, it is the 3 minute. Total time cycle, if you look at this, then 30, 60 and this 3 minute, then it is going to be this 90 second, and 90 plus 180 is going to around the 270 second, or it is going to be around the 4.5 minutes. So 4.5 minutes, it is the total time cycle in case of the histamine. So this is another very important experimental parameter that you need to keep constant throughout the experiment. So now before going ahead with the actual DRC, first we'll see about the receptor binding of the histamine and principle of the matching bioassay. So do remember, since histamine, it binds to the histaminic receptor. So those receptors are called as the histaminergic, because the histaminergic receptor are very specific. They are present in the different part of the body, and one of the part of the body, it is your gastrointestinal tract. So most of the time, this histaminergic receptor, when the histamine bind to the histaminergic receptor, it produces the contraction of the smooth muscle. So when you come in the final year, you can see or when you study the autopoid chapter, where the histamine, it is the one of the important autopoid. So there you will come to know, when histamine bind to any smooth muscle or the histaminergic receptor in the smooth muscle, it produces the contraction of that particular smooth muscle. So what you are studying here in this case, when you are allowing the standard histamine concentration to be in contact with the tissue, so that is till particular time, so that is for 60 seconds, so you call it as the contact time, so that the drug can bind to the histaminergic receptor and it can produce as the contraction. So you increase the dose and you study how increase in the dose lead to increase in the contraction of your guinea pig ileum. Okay, so the mechanism, it is very simple. The binding of the histamine to the histaminergic receptor, it produces the contraction. Second important thing is about the principle of the bioassay, because here we are studying the different type of bioassay, that is matching bioassay. So the procedural part we have already seen. So what we are doing in case of the matching bioassay, we are trying to match response of the standard dose with the response of the test dose. Now when you are doing this, when you are trying to match response of your standard dose with the response of the test dose, in this particular process, the amount of drug it is required, so especially the amount of the test drug, if it is required, it is generally less. Why? Because you are taking only few doses of the test, whereas in case of the standard, you have used the standard dose to take the DRC like 0.1, 0.2, 0.4, 0.8, 1.6 and 3.2. You have taken n number of doses of the standard, whereas in case of the test, you have taken only 1 or 2 doses. just to bring that the response of the test dose within the DRC. That is for the selection of the test. For that purpose only you have used the test dose. Whereas the standard, again you are using multiple doses so that the dose of the standard can match with the test. So looking at this, the amount of standard dose of the histamine required, it is more as compared to amount of the test dose required in this particular experiment. So now suppose when you perform the experiment, or when you do the investigation, and if you have synthesized some biological molecules, or maybe you have isolated some molecule from the herbal extract, and if the concentration or the amount of the drug which is available with you, if it is less, then in that case, instead of going for lengthy experiment of the 3-point bioassay or the 4-point bioassay that we are going to study in upcoming practicals, so instead of going for that, either you can select the matching bioassay, bracketing bioassay, or interpolation bioassay. So the most important advantage of this method is it is generally used when sample size is very small. So now suppose if you have used maybe the 4 kg of the leaf, and from that particular leaf you have just isolated 100 microgram of the active molecules. Now since the molecule isolated by you, it is just 100 microgram. So whatever molecule you have isolated through the lengthy procedure, it is very precious. So you should not waste it for doing any other bioassay where the more amount of drug is required. So you have to be very particular in selection of the drug. So that is the reason in such cases you can use either matching bioassay or the bracketing bioassay, where amount of drug required, it is very less. So one of the assay is the matching bioassay. It is used when sample size is very small. So that is very important advantage of the matching bioassay. So this is basically the principle of the matching bioassay, where you are trying to match response of the standard with the response of the test dose. Now let's see how to perform this experiment. So first we need to take the DRC of the histamine, and second part it is we need to match the dose of the standard or the response of the standard with the response of the test drug. Okay, so let's start with the DRC. So DRC process, it is same as we have studied in case of acetylcholine bioassay, where we have to start with the lowest possible dose of 0.1 ml. Okay, and we know that when we take these responses at first level, we repeat the dose of 0.1 ml. So we are again going to give the same dose of the 0.1 ml. So when you have given the same dose of the 0.1 ml, and when you see that it gives the same height of the responses, so in both the cases you are getting the similar response height, then this process, it is called as equipotency. So especially those who are D-Pharm student who have joined later on, direct second year admitted student, so you have missed this part in case of acetylcholine bioassay. So you concentrate here and try to understand about this simple process of the DRC of the histamine. Okay, so the process, it is same for DRC of the histamine, DRC of acetylcholine by using cock ileum as well as rectus abdominis muscle preparation. So first important thing is that the equipotency, where you are repeating the 0.1 ml dose or the lowest possible dose that you have started with, and when at the same dose when you get same response, so that is called as equipotency. Then secondly, now since you have checked the equipotency, so the equipotency, it indicates that your tissue, it is stable. It means your tissue can give you reproducible responses. Means if you give the 0.1 ml, both the same dose, it is giving same response. It clearly indicates that here your tissue giving reproducible responses. Now suppose tissue, if it is not giving reproducible response, then it might happen that at 0.1 ml when you have given the second dose, it will give you either less response or it will give you more response. So that indicates that your tissue, it is not yet stable or it is not completely relaxed, and in that case you have to first relax the tissue and then you can go ahead with the remaining dose of the experiment. So now here, since you are getting the same response at same dose, so you have ensured that there is equipotency and your tissue, it is stable and giving reproducible responses. Now what you can do, you can give the next dose, that is the 0.2 ml. So now when you are given the 0.2 ml dose, you can see the response height, it is increased as compared to the 0.1 ml. Likewise, then you can give the next dose of the 0.4 ml. So again, as dose is increased, there is increase in a response. Likewise, you can increase the dose, keep on increasing the dose and keep on taking the responses till you get the ceiling effect. Now what is ceiling effect? Now you look at these two important responses, that is 1.6 and 3.2. If you look at these responses, then the response height of both 1.6 and 3.2 it is same. Although here you have given the double dose. So 3.2 it is exactly double of 1.6, but since you have getting the same responses, so this indicate that the ceiling effect has been reached, and this indicate that all histaminergic receptors are saturated and occupied by the histamine. So now since there is no more histaminergic receptor are present, so although you increase the dose, but it won't give increase in a response height, because the number of histaminergic receptor present in your tissues are limited. Now since all these receptors are saturated, although you have given the double dose, but it won't give increase in the response. So here in this case of two doses, so 1.6 dose, it is called as the maximum dose. So I am writing it as a M, so it is called as the maximum response, because this is something which is the maximum height amongst all these responses. Whereas 3.2, it is called as the ceiling dose. Why? Because although you have increases the response, but increases the dose, but there is no further increase in a response. So this is called as the ceiling dose. So I am writing it as the CD. So that is indicate that this is the ceiling dose. Now once it is done, now your DRC of the standard it is over. Okay, so you have to take DRC of only histamine, especially in case of the standard solution, for which concentration it is known to you. Now this DRC of histamine it is over. Now once it is done, after that you have to give one more dose of the histamine. So you have given another dose of the histamine, and the dose that you are generally selecting here, you must select it as a submax dose. So what is the submax dose here? Any dose which is less than the maximum dose. So what is maximum dose? So maximum dose it is the 1.6 that we have already seen. So any dose which is less than maximum, that is 0.8, 0.4, 0.2, 0.1, these are all submax dose. So you have given one more submax dose after the ceiling effect, and you can just check their height. So now if the height of this 0.8 ml and this 0.8 ml, if it is same, that indicate that your tissue it is still stable, because at submax dose before ceiling effect and after ceiling effect their height it is still same. So this clearly indicate that your tissue it is still stable and it is giving reproducible responses. Now we have done with the DRC of only histamine. Now we are giving the next dose, it is of the test. So you remember that we have seen in case of procedure, first step it is taking the DRC of the standard. So we have done with the DRC of the standard. Second step, it is the selection of test dose. So now when we are selecting test dose, do remember that the height of the test dose whatever we select, it must be bigger than the smaller response of the standard, and it must be the lesser than the biggest response of the standard. Now here which one is the biggest response? It is 1.6, and the smallest response it is of the 1.1. So whatever dose we select, their response height, I am talking about a response height, not a dose. So their response height it must be bigger than 0.1 ml, and it must be smaller than the response height of 1.6 ml. So now we can start with the test dose. So you can start with any test dose, and then you can accordingly adjust the next dose. So suppose if you have started with 0.1 ml of the test dose, we have taken the response, and now our observation is that the 0.1 ml of the test dose, their response it is smaller than 0.1 ml. That is the smaller response of the standard. So you are not going to select this. So you have to select the response which must be bigger than 0.1 ml. So what you can do, you can give the next dose, that is the 0.2 ml. And when you are given the 0.2 ml, you have observed that the response height it is bigger than this 0.1 ml, isn't it? Now the moment when you select the response height which is bigger than 0.1 ml, suppose if this is of the suppose if it is the 15 mm, अगर ये आपका 15 mm अगर आपका height है, and if it is coming to the 17 mm, it means it is bigger, right? Because this is the 17 and this is the 15 mm. So now you have already selected the dose of the test. So if needed, then you can repeat again 0.2 ml of the test, or if sample size it is very less, if you have very less sample, then you can avoid. But if you want to confirm, you can repeat the 0.2 ml of the test and you can check whether at 0.2 ml if it is giving same response height or not. So the confirmation can be done, but it is not compulsory. So at this moment, the selection of test dose it is done, which is bigger than the smallest response height of the standard and which is the smaller than the biggest response height of the standard. After this, now the third stage of this experiment, it is the matching of the response height of the standard with the response height of the test. Okay, so you will start that. So you can start with the first dose of the standard, that is 0.1 ml. So when you have given the 0.1 ml of the standard, you observe that it is giving the height up to maybe the which is that is the 15 mm. Obviously, when you are giving the 0.1 ml, it is going to give you a height of the 15 mm only because the dose it is same. Okay, so now suppose if you got height here of the 15 mm, so now you can guess what could be the dose which can give you a response height which that can match with the response height of the test. So you want the response height of the standard which having the height of 17 mm. So instead of directly giving 0.2 ml, you can select or you can just guess and then accordingly adjust the dose. So now I am not giving 0.2 ml, I am giving the dose of 0.15 ml. And when I have given the 0.15 ml, I have observed that now this height it is matching. Okay, so now this height of the standard it matches with the dose of the test. Sometimes it doesn't match, sometimes you may get less or you may get more. Then in that case, instead of 0.15 you can use 0.12, you can use 0.13 or you can use 0.17 if it is you are getting the less height. So you can slowly increase the dose. So ultimate purpose is that the response height of the standard it must match with the response height of the test. Now once it is done, then you need to measure the response height, and now the bioassay part it is over. Okay, so you know that your dose of the test that you have selected it is the 0.2 ml, and the dose of the standard that matches their response it is matches with the test dose it is the 0.15 ml. So these are the two doses that you have selected, and you also know the what is standard concentration of the histamine. So based on this, you can use the formula for calculation of unknown concentration by using matching bioassay. So what is that formula? The formula is Ct is equal to y by x multiplied by Cs. So now here the Ct it is the concentration of the test, y it is the dose of the standard that matches with the response height of the dose of the test. So this is what is that dose? Y it is the 0.15, that is the dose of the standard that matches with the response height of the dose of the test. Then what is the x? X it is the dose of the test selected. So what is the dose of test you have selected? It is the 0.2 ml. And Cs it is the concentration of the standard. So that is will be given to you, and you can put simply that in the formula. You will get the unknown concentration by using matching bioassay. So let's try to understand this by using the readings. So I have given you an Excel workbook. So you open that Excel workbook. I'm going to open now that Excel workbook. So here you can see I already opened this. Let me minimize it and let me reduce some percentage so that the calculation can be nicely visible to you. So this Excel workbook it is given to you, that is DRC of the histamine matching bioassay at different doses, different responses of the histamine you received, and you can see here the standard dose it is given, that is 10 microgram per ml. So the standard dose it is 10 microgram per ml that you have to put into the formula. Now what dose of the test you have selected? Dose of the test dose of the histamine selected in the ml it is 0.2 ml. Okay, so this dose it is in a ml, but you need to calculate unknown concentration in microgram per ml. So test dose of the histamine selected is 0.2 ml. Then dose of the standard that matches with the test dose of the histamine it is 0.1 ml. So now based on that you need to calculate unknown concentration of histamine by using matching bioassay. So what I'm doing, I'm simply taking this formula over here and just let's copy paste this formula in an Excel Google sheet. Okay. Yes, so now you can see, let me increase the size so that it can be nicely visible to you. Okay, little bit more. Hope it is visible to you. Now we have seen what is the y here. So is equal to, now what is the CT? CT, it is the unknown concentration of test that you need to calculate. Now what is Y here? The Y here, it is dose of the standard that matches with the test dose of the histamine. So I am is equal to how much it is? 0.15. So I have selected 0.15 divided by what is X? X, we have seen that it is the test dose of histamine selected. So it is the 0.2 ml. So that I have selected. Then all this value I am just simply putting into the bracket. Okay. And then that will be multiplied by CS, it is the concentration of the standard. So how much it is? It is 10 micrograms. So that will be multiplied by 10. Okay, so simply I am multiplying that value by the 10. So now you can get, you can see you got the value that is 7.5. Okay, so this 7.5, the value you got, it is the unknown concentration in microgram per ml. So this is how, by using the matching bioassay, we can calculate unknown concentration of the histamine. So simply, just to revise it, very important thing is that first you are taking the DRC of the histamine. No need to calculate percentage response as we have calculated in the case of acetylcholine bioassay. And second thing is that you need to select the test dose of the histamine which fall between the smaller dose of the standard and bigger dose of the standard. So selection of the test dose. So that you have done that, you got it is the 0.2 ml. Then you have matches the dose of the standard with the response height with the of the test dose that you have selected. So that you have selected as 0.15, and then by using the simple formula, the CT is equal to Y by X multiplied by CS, you have calculated unknown concentration, that is the 7.5 ml. So this is the simple way. Now I have already disclosed you the answer. So simply you can calculate it and you can copy paste this particular table in your journal. Then you write this value in case of the result, that is 7.5 ml microgram per ml, and simply you have to submit your journal. So this is all about today's experiment, that is the matching bioassay. I have done with my session. So thanks for watching my session. If you like my session, then do remember to give me a thumbs up, and for more such learning, subscribe to my channel.